Hello, everybody. We're going to look at a new type of formula now, and this formula is called recursive formula. It's a very simple concept to understand because it's just stating a pattern. A little complex to write, so bear with me as I go over the do's and don'ts of how you actually write these. Okay, so here's what a recursive formula looks like. All right, so I'm gonna rewrite this. Okay, so just like an explicit formula, you can start it with a sub n, all right? Except this one, right, instead of just defining the function and having an n as an input, this one's gonna have another term. It's gonna have a sub n minus 1, and that means something, all right? So let's say I have a sub n equals a sub n minus 1 plus 5, comma, a sub 1 equals 10. So that's your first example of a recursive formula. Here's why it's recursive. Recursive, like recurring, all right? It is reoccurring. Something that's reoccurring is a pattern. I like to think of recursive formulas as pattern formulas. They simply tell you the pattern, all right? Now, I think most of us could interpret what a sub 1 equals 10 means. Well, that means the first term is 10. So I like to visualize the sequence. The first term is going to be 10. Okay, that's all I know at this point. So let's look at the formula. The formula says a sub n equals a sub n minus 1 plus 5. What does that mean? Well, a sub n simply means a term. All right, cursive is better for me. That's a term. A sub n minus 1, don't think of substituting or anything like that. A sub n minus 1 simply means the previous term. All right, previous term. All right, that means if I have a number, a sub n minus 1 is the previous number. So it says any term is equal to the previous term plus 5. Okay, well, that's pretty simple to understand. Any term in the sequence is the one right before it, but 5 more. Okay, so if 10 is the number right before this guy, that means this guy's got to be, well, 10 plus 5 equals 15. And that must make this guy 20, which would make this guy 25, etc., etc., etc. All right. So this is an example of an arithmetic sequence. All right. So once again, I need to state the first term and I need to state the pattern. Well, the pattern is just you add 5. Okay, so that's the way that recursive formula is going to work. All right, so whenever you see a sub n minus 1, I wrote right here, please say this in English. Whenever you say a sub n minus 1, you can rename that previous. A sub n minus 1 simply means previous. That's all it means. All right, because if I have a sub 5, for example, then a sub n minus 1 is going to be a sub 4. So a sub 5 would mean the 5th term. The previous one would be the 4th term. So the 5th term is going to be the 4th term plus 5. The 2nd term is going to be the 1st term plus 5, etc., etc. That's all that means. All right. So don't worry. Be happy. All right. Now, what about geometric sequences? Well, it actually does not change that much. For a geometric sequence, we have a very similar format. All right. So for this one, we've got a sub n equals 5 times a sub n minus 1, which means the previous. So we take the previous term and we multiply it by 5. And we make sure to mention where we start. If you don't mention the first term, then you don't know how to start writing this sequence. So I'm going to start writing it. The first term is 4, and this says 5 times the previous. So 5 times the previous, that means this guy is 5 times 4. So this must be 20, right? Which means that next one should be 100, all right? Because it's 5 times greater. That's all that means. So your format for geometric is going to be a sub, and this should be a sub n, all right? A sub n equals a sub n minus 1 times r. You can put the r at the end, or you can put it in front as a coefficient or behind. It does not matter as long as you multiply. And as always, you need to state the first term. So that is, in a nutshell, how recursive formulas work. Always state the first term. Always state the pattern. The pattern is either the common difference or the common ratio. Let's go.